Hi, this is Chioma, and I will be explaining how I got my answers for my test. Starting with number 1, I got my answers. I figured out 1A as racer 1 wins, and I did this by calculating the area under the graph. And the area under the graph gives you the displacement. So after I calculated the area for racer 1, it showed that racer 1 went 24 meters and racer 2 went 20 meters. So racer 1 won. And then at time equals 5, which of the following statements are true? I put racer 2 is not accelerating, and we can see that because the line is horizontal. Racer 1 has a positive velocity, racer 2 has a positive velocity. We just see that on the graph right here, all the velocity is positive. And racer 1 is winning, and this is because the area under the graph of racer 1 is bigger than that of racer 2. At 5 seconds, as we can see here, the area under the graph is bigger. Racer 1 had an area of 17 meters, and racer 2 had an area of around 6. And then for C, it says sketch the position and acceleration graphs for racer 1 and racer 2 as a function of time. The velocity graph is given below. So this is my position versus time graph. The black is for racer 1, the pink is racer 2. And I got this by just calculating the position at each time. So that's what I did here. And then I plotted it. I calculated it by actually finding the area for each and every second to give me the displacement. And then I plotted it. And then for the acceleration graph, this is racer 1's acceleration graph. And I found the acceleration by the change in velocity over change in time at each point of time. I worked that out. And so for racer 1, this is what I got for acceleration, and for racer 2, this is what I got. For question number 2, I just described Newton's laws. There wasn't anything to work out, so I just described Newton's laws, how I remember them. For question number 4, I made note of the different forces that are acting upon each block. And from there, I made like a formula for force. So force equals mass times acceleration, and the force we have here is both T1, that's our tension force, and our gravity and mass equals ma. And then so I did the same thing for block 2 and the same thing for block 3. So for scenario 1, I worked it out and I tried to find the max value of the static friction force. And the reason we use static friction is because it's not moving. So then I worked it out. And then you find the gravitational force of M1, which in scenario 1, M1 has a really light mass. So because of that, the gravitational force is lower than the static friction mass, so the block will not move. And then scenario 2, we're actually going to use kinetic force. And the reason we use this is because the blocks are actually going to move in kinetic force because the mass is a lot greater for block 1. So I worked that out for the blocks. And then, so after I worked that out, then I made this formula, and this formula is actually just a combination of these formulas that are here because we need all of them. So when you work that out, you get your acceleration at 9. And then you're gonna need relative acceleration. So then you work that out, it gives you 18. And this is actually this is supposed to be length. Sure, let's make it, that looks like an L. Length. And so we're finding the length right here, which is 2 inches, but you want to convert it to meters. So this is the formula for the length. So we can get our T. And when you flip it around, this is what you get. This is 2 inches in meters. And when you work it out, you get 0.075 seconds. For number 5, we're gonna be trying to find like the kinetic friction force. And the reason we're using kinetic friction is because the object is moving. So here's our formula. And then when you just plug in the numbers that were given, and so this is our force. And so after finding that, we need, how far does it travel? We need a formula to include our initial velocity after getting our force. So for force and initial velocity, here's a formula to use so we can find out just how far it travels. So we're gonna be using this. And then when you plug in the numbers again and work it out, you get 4.08 meters. For number 3, we just make note of, I just made note of the values that I do have. And in order to find what I'm looking for, I needed a lot more values. And so I used different formulas to find the y, which I did the hypotenuse formula, and acceleration. And then to find velocity final, I used the numbers and I just kept plugging it in to find the different values that I needed until I got to x.